What is a photon? Photon is the smallest unit of light.
So how is it supposed to be useful? I was talking to my cousin and he asked me how did they get their outer space modern technology. My reply, it all started with the small things, like a photon. Now let's take a case study. Photoelectric effect. It is the emission of electrically charged particles from a material when it absorbs electromagnetic radiation, like light. Back then, scientists could not explain this using the classical or wave theory of light. There are four basic observations of the photoelectric effect. 1. The emission of electrons only occurs above a certain frequency called the threshold frequency. The threshold frequency is the particular frequency where emission of electron occurs for a particular material. Emission of electron is instantaneous. 3. The number of electrons that are emitted is proportional to the intensity of the incident radiation. And 4. The kinetic energy of the electrons is proportional to how high the frequency of the incident radiation is above the threshold frequency and not on the intensity. Classical physics could only explain observation 3 since more electrons will absorb sufficient energy from the high intensity radiation and be emitted. It was Einstein who proved this by using Planck's theory of black body radiation, that light or radiation travels in packets called quanta and each has energy E equals hf. Einstein said light also contains tiny particles called photons, and these photons also have the same energy E equal hf. Einstein won a Nobel Prize for this. How? Let's prove it ourselves. You see, when a photon combines with an electron, some of its energy goes to break binding forces and some of it is used as kinetic energy for the electron to escape. That is, the energy of an electron hf is equal to the energy to break binding forces work function plus the kinetic energy of the emitted electron. To solve observation 1, hf must be greater than the work function, that is, hf must be greater than hf naught, hence f must be greater than f naught. Increase in intensity means increasing the number of photons, hence observation 3 solved since each photon releases an electron. To solve observation 4, we use hf equal work function plus kinetic energy, hence kinetic energy is equal to hf minus work function, that is hf minus hf naught. We have h into f minus f naught, hence the kinetic energy depends on the frequency and not on the intensity. Wow, we proved the groundbreaking photoelectric effect in a very simple way. Always look up in the sky and believe you can do it.